Hi everyone. Today we will talk about the Lewis structure for the organic compounds. Of course, if you want to draw the structure for any compound, we have a way to make that. The first way to draw the structure of organic compound is the Lewis structure. Lewis structure are electron dot representation for molecules. There are three general rules for drawing Lewis structures. That meaning we have three rules. Number one, draw only the valence electron. What meaning valence electron again? Just the out shell electrons, the electron in the outer shell. Okay. Second, give every second row elements no more than 8 electrons. That meaning all the atoms in the periodic table for the second row, like carbon, sulfur, nitrogen, halogen, okay, no more than 8 electrons. Look to here. If you look to this structure here for the floor, calculate the dot here: 1 2 3 4 5 5 6 7 8. That meaning just 8 electrons. Okay, for every 2 electron between two atoms, it's referred to one bond. Third, give each hydrogen 2 electrons. For every hydrogen, always 2 electrons. And to draw a Lewis structure for diatomic molecule. Diatomic molecule, that meaning molecule contain 2 atoms. Okay, like HF, we have hydrogen and the fluor. Recall that hydrogen has 1 valence electron. That meaning the hydrogen has 1 electron in the outer shell, and the fluorine has 7 electrons in the outer shell, on the valence electron. Hydrogen and the fluor each donate that meaning sharing electrons. Okay, not transfer. If we say share, that meaning is equivalent bond, not ionic bond. Donate 1 electron to form 2 electron bond. The resulting molecule give both hydrogen and fluor a filled valence shell. That meaning filled valence shell. That meaning full electrons. For the hydrogen, 2 electrons. Look to here. Hydrogen, we have 1 electron, and the fluor we have 7. If they sharing their electrons between of them, that meaning calculate for the hydrogen it would be 2 electron. It will be stable now because the outer shell of the hydrogen is the s orbital, and s orbital consists from 2 electrons, no more than 2 electrons. And the fluor, s orbital and p. S orbital 2 electrons, and p 3 orbital, py or pz or px, it will be 6 electron. It will be contained from 8 electron. 1 2 3 4 5 6 8 8, like noble gas. 8 electron in the outer shell, it will be stable. Okay, and for every 2 electrons between 2 atoms can be converted to the short line here meaning bond contain from 2 electron all times. Okay, there is no bond from 3 electrons or 4, just for every 1 bond 2 electrons. In Lewis structure, a solid line again indicate 2 electrons covalent bond. Okay, here we said before that the hydrogen is monoequivalent, that meaning make just 1 bond. Okay, then you cannot draw 2 atom bond to the hydrogen. It falls. Okay, it is big wrong in organic chemistry. And the carbon tetravalent, we say that 1 2 3 4 bonds always. And the nitrogen trivalent 1 2 3, and we have unshared of electron here, unshared non-bond electrons. Okay, non-bonded 1 2 3. For every times memorize this: the nitrogen is trivalent and the oxygen is divalent with 2 unshaped of electron, and the halogen is also like hydrogen, the halogens also monovalent, and there is 3 unshaped of electron around the atom. And here a procedure for drawing Lewis structure. We have rule here, okay? If I say to you, I give you for example molecular formula or chemical formula, I say to you convert this chemical formula or molecular formula to the structure or to the Lewis structure. Okay. Step 1, arrange atoms next to each other that you think are bound together. Okay, you have to think the hydrogen is bound to the carbon or to the hydrogen or like that. Okay, for example here, always place hydrogen atoms and the halogen atoms on the periphery, because what meaning periphery? يعني around the atom. The atom is more valence from the other. Okay, why? Because always the hydrogen we said before and the halogen, it is just has one bond. Okay, cannot put the hydrogen in the middle here and put the carbon, because the hydrogen it will be 4 bond. This is almost okay. This is impossible, and from only one bond for each other. Look to this, we have here 4 hydrogen and 1 carbon. Carbon tetravalent, that meaning the carbon it will be in the middle. Don't put the hydrogen again in the middle, and not like this. Don't say hydrogen it will be to hydrogen and it will be bonded to the carbon, because this hydrogen it will be divalent, and this is mistake because the hydrogen is monovalent. Here, as a third approximation, place no more atoms around an atom that the number of bonds it usually form. What meaning that? Then if you said you know the nitrogen is tetravalent, that meaning the nitrogen bonded to the 3 atom, that meaning 1 2 3. Don't put hydrogen here. If you put the hydrogen here it will be mistake. Why? Because you have to bond to make bond between the nitrogen and the halogen, and here bond also the 4th bond. Then the result for the nitrogen will be 4 bond, and this is mistake, wrong. Okay, for carbon, put around the carbon 4 atoms. Why? Because the carbon is tetravalent. Put around, for example, the hydrogen just 1 atom. Why? Because the hydrogen is monovalent, and like that. Now step number 2, count the electrons. Count the number of valence electron from all atoms. Okay, add 1 electron for each negative charge. That meaning if you have an ion atom with negative charge, that meaning you have to add excess 1 electron. Subtract 1 electron from each positive charge. If you have cation with positive charge, you have to remove 1 electron. Okay, this is from the count of electron. You have to calculate the number of electron. This sum gives a total number of electrons that must be used in drawing for the Lewis structure. Okay. Step number 3, arrange the electron around the atom. Again, place a bond between every 2 atoms. Give 2 electrons to each hydrogen again, and no more than 8 electrons for the second row atoms. Use all remaining electrons to fill octet with lone pair. Okay, that meaning you have to put a shape of electron. If all valence electrons are used and an atom doesn't have an octet, that meaning if you draw all the bond between the atoms and you saw there is excess electrons remaining, you have to think for the double bond and a triple bond. We will take examples in the next slides. Assign formula charge to all atom. Okay, that meaning if you have positive or negative charge, you have to think and to put the where is the negative or the positive charge on the any atom, if there is any excess electron or there is any other mistake. Now look to this example. Draw the Lewis structure for the methane. Now arrange the atom. We will put the carbon, because the carbon is tetravalent, and around the carbon we will put the hydrogen. Calculate the electrons. For we have one carbon, and for every carbon 4 electron, it will be equal to 4, and we have 4 hydrogen. For every one hydrogen, 1 electron, it will be 4 also. Now 4 plus 4, it will be 8, the total electrons for this structure. Now added the bonds we will put between every two atoms. We say that one short line, this is the bond. That meaning here one short, here one bond, here one bond, also here one bond. And for every one bond, we say it consists from the 2 electrons. That meaning we have 4 bond, and for every bond 2 electron, it will be total to 8 electron. That meaning our structure is now right, and there is no any mistake. Now if you finish from the structure, you have to ask yourself 3 questions. Have all the electrons been used? 8 electron, we used 8 electron here. Yes, right. The second question, is each hydrogen surrounded by 2 electrons? We have hydrogen here, 2 electrons, this hydrogen 2 electrons, this hydrogen 2, and this hydrogen 2. Yes, right. Is each second row element surrounded by no more than 8 electrons? Where is the second row element here? The carbon. There is 8 electrons around the carbon? 1 2 3 4 5 6 6. Yes, 8 electrons. That meaning your structure is now right, and there is no any mistake. If there is any question from this, is the answer is wrong, that meaning there is a mistake in your structure, and you have to come back to draw again the structure. Take this the second example. Draw the Lewis structure for this chemical formula CH4O. Okay, step number 1, arrange the atom like this. We cannot put the oxygen here or the hydrogen here because the oxygen is divalent, and now we put 2 atoms around the oxygen, and the carbon is tetravalent, and we have here 4 bonds around 4 atoms around the carbon. And for we said the hydrogen, it will be the position of the hydrogen always, and the halogen will be in the ocean of the molecule surrounded the molecule. And step number 2, count the electron. For we have 1 carbon, that meaning 4. We have 1 oxygen. For the oxygen is equal to 6 electron. Why? Because we have 2 unshaped of electron on the oxygen. Remember that this is so important here. Okay, we have 1 electron here from one electron with the hydrogen, and we have 2 unshaped of electron in the oxygen. That meaning for the total number of electron for the oxygen always to be 6. Okay, not 4, because the oxygen is divalent and there is 2 unshaped of electron on the oxygen atom. We have 4 hydrogen, and multiply by 1, it will be equal to 4. That meaning the total number of electrons, it will be equal to 14. Now you have 14 electron. You have to put this electron between the atom. Okay, now this the hydrogen 2, here 2, here 2, here 2 electron, and also here 2 electron. Now Now calculate the number of electron here. It will be equal to 10. That meaning there is 4 electron remaining. Okay, whereas we put the electron here on the hydrogen? No. Why? Because the hydrogen always we say 2 electron, and we can put the 2 electron or the 4 electron on the carbon? No. Why? Because the carbon now is 8 electron. Octet rule, 8 electron, no more than 8 electron. Okay, we can put the 4 electron on the oxygen? Yes. Why? Because now here 1 2 3 4, and oxygen needed another 4 electron to be in the octet rule. Okay, to be has 8 electrons. That meaning the remaining 4 electron, it will be on the oxygen atom like this, and now our structure is right. Now this homework for you. Try to draw the Lewis structure for this molecular formula. Now for multiple bond, we said before that also calculate the number of electron. For example, for the ethylene C2H4, now we have 2 carbon. For every 1 carbon 4 that we need, it will be 8. We have 4 hydrogen, that meaning the total number of electron, it will be 12. Now put the atoms near from each other. It will be like that, and put the bonds, it will be like that, 1 2 3 4. Now are this carbon surrounded by 8 electron? The answer is no. This carbon surrounded by 6 electron, 1 2 3 4 5 6. That meaning we have 2 remaining electron. Are this carbon surrounded by the electron? No. The answer is also no. No, we can put the remaining 2 electron in the one of them, one of the carbon. If you put the 2 electron here, this carbon will be surrounded by 8 electron, but this carbon is not an octet role. That meaning it will be not surrounded by electron. That meaning also this formula is false, not true. Okay, what we have to do now, we have to put 1 electron here and 1 electron here, as in the next slide. That meaning move 1 electron from this carbon to this, it will be make double bond. Now calculate the number of electron here in this carbon. 1 2 3 4 5 6 7 8. Yes, but for this carbon also 8, surrounded by 8 electron. Now our structure is right. The same thing for the acetylene. The acetylene, if you calculate, it will be the summation of electron, it will be total for the 8 electron, for the 10 electron, and if you put here the atoms from each other, it will be 1 2 3 4 5 6. That meaning we have 4 remaining electron. We can put the 4 electron in the one of the carbon. The answer is no, because this it will be in the octet rule, and this atom it will be not in the octet rule. What we have to do, okay, remove 2 electrons from each carbon to the other, and this it will be make bond, and the other it will be make another bond. It will be triple bond, as the next slide. That's triple bond between the carbon carbon atoms. Now calculate the number of electron here. 1 2 3 4 5 6 7 8. Yes, octet rule, and also the other carbon the same thing in the octet rule. And here you have homework for you. Try to resolve this homework, and again I will repeat again, please. When you study organic chemistry, take a pen and paper and write everything. Formal charge. I will stop here, and we will take this subject in the next lecture, inshallah. See you.